Have you ever stopped to consider where the gold on your ring, the iron in your blood, or the uranium powering entire cities actually came from? The answer isn't found in the ground beneath your feet, nor did it originate anywhere on our planet. In fact, the story of these elements begins in one of the most dramatic and violent events in the cosmos: the explosive death of a massive star, an event known as a supernova. Picture this. Billions of years ago, before the Earth was even a twinkle in the universe's eye, a star many times larger than our Sun lived out its final moments. It wasn't a quiet fading, but a cosmic detonation so powerful that for a brief moment, it could outshine an entire galaxy. In that split second, the universe witnessed an alchemy more extraordinary than anything dreamed of by medieval scientists: the forging and scattering of the heaviest, rarest elements. But how does a star, an immense ball of burning gas, become the birthplace for elements as precious as gold, as essential as iron, or as mysterious as uranium? To answer this, we need to journey back to the fundamental building blocks of the universe: the stars themselves. Stars are born in vast clouds of gas and dust, known as nebulae. Gravity pulls these clouds together, compressing them until the pressure and temperature soar to unimaginable levels. Deep in the core of a newborn star, hydrogen atoms begin to fuse, forming helium and releasing tremendous energy, a process that makes the star shine. For millions or even billions of years, this fusion continues, with the star converting lighter elements into heavier ones in its core, quietly building up a layered structure like an onion. But even stars have lifespans. The more massive the star, the faster it burns its fuel, and the more dramatic its fate. As the star ages, it runs out of hydrogen and begins fusing heavier elements: helium into carbon, carbon into oxygen, and so on, climbing the periodic table. Yet there is a limit. When the star's core is made of iron, fusion grinds to a halt. Iron is the dead end, the element that refuses to release energy when fused. The core becomes unstable, and gravity, no longer opposed by the outward pressure of fusion, wins the final tug of war. What happens next is nothing short of cosmic catastrophe. The core collapses in on itself in a fraction of a second, reaching densities so extreme that atoms are crushed together. The outer layers of the star rebound off the core with titanic force, unleashing a shockwave that rips the star apart. This is the supernova, one of the most energetic events in the universe. But the real magic happens in this moment of destruction. The shockwave provides the energy needed to fuse elements heavier than iron, forging gold, uranium, and dozens of other elements in a process called nucleosynthesis. These newly minted atoms are flung into space, carried on the expanding shell of stellar debris. For a brief time, the galaxy is seeded with the raw materials for planets, moons, and eventually life itself. The ashes of dead stars become the dust of new solar systems. Over eons, gravity gathers this debris, forming new stars, planets, and everything that exists on them. The gold in your jewelry, the calcium in your bones, the oxygen in your breath, all of it was born in the heart of a star and scattered across the cosmos by a supernova explosion. But the story doesn't end there. These cosmic furnaces are rare and precious in themselves. Not every star gets to go out with such a bang. Only the most massive stars, those at least 8 times the mass of our Sun, have the right ingredients for a supernova. Smaller stars, like our own, will end their lives more gently, puffing away their outer layers to leave behind a white dwarf. It is the biggest and brightest stars that get to write the universe's final chapters in gold and platinum. So, how do we know all this? Astronomers have been piecing together the evidence for decades. They observe the light and energy from distant supernovae, measure the abundance of elements in ancient stars, and even detect the ghostly neutrinos that escape from stellar cores. Each clue points to the same conclusion: the universe is a vast recycling machine, and supernovae are its most spectacular engines. Consider this: every atom of oxygen you breathe, every drop of iron in your blood, was once at the heart of a star. The very atoms that make up your body were forged in cosmic fire, scattered across space, and gathered together by the pull of gravity to become you. You are, Quite literally, stardust, an echo of explosions that happened billions of years ago. And what about the future? Somewhere in the Milky Way, massive stars are living out their final days, preparing for their own spectacular deaths. When they explode, they will send out new waves of elements, ensuring that the cycle continues. New planets will form, new life may arise, and the story of the universe will be told in the language of the elements. So, next time you admire a piece of gold jewelry or consider the power of a nuclear reactor, remember, these are not just earthly treasures. They are cosmic gifts, born in the death throes of ancient stars. The universe is written in the ashes of supernovae, and we are all participants in this grand celestial story. What else might we discover as we continue to study the remnants of these stellar giants? Could the next supernova reveal secrets about the origins of life itself? The universe is full of mysteries, but one thing is certain. In the heart of every human, in the foundation of every mountain, and in every ounce of shining metal, there is a history written in stardust, waiting to be uncovered.